好，开始。
Hello everyone, my name is Emily and my name is Ivy. Today we're going to talk about the intermediate value theorem.
好，刚刚你在介绍自己的时候，那个动画就要按了。
Continuity is must be satisfied before we talk about the intermediate value theorem. And before, we never really talk about how we can make sure that a function is continuous. So today we want to explain more about this property. So Ivy, what do you think a continuous function is?
I think I can draw a continuous function with one stroke.
Yes, exactly. So if you look at this picture, and we use a pencil to draw the function, without lifting the pen, we can finish drawing it. It means that it is continuous. There are also other ways to define whether a graph is continuous. We can draw many tangent lines. And from this picture, we can see that all these tangent lines form a smooth and continuous picture. We can see that this star can travel through the whole picture without stopping or disappearing. It means that this picture is continuous. And same with this hyperbola. The stars can travel through the whole picture, and they move very smoothly, and they did not stop or disappear. It means that it is continuous. So, let's talk about the definition of intermediate value theorem. We now look at this picture. We know that it is continuous from point A to point B. And now we find a y value w between f of A and f of B. And from this graph, we can see that for every y value w, we can find a matching x value c between A and B, because this graph takes on every y value between point A and point B. And here is another example to illustrate the intermediate value theorem. An earthworm must be continuous. Don't tell me that we break it in half, not yet. It is now a continuous, it represents a continuous function, and from the head to the tail, we stick it at point A at A and point B at B. Between point y value f A and f B, we can stick the needle, and it can be located between f A and f B. And if we stick it through, we can be 100% sure that we will stick through the worm. Yet there is but we cannot make sure that if the inverse statement of the intermediate value theorem is not necessarily correct, because we can now see that this earthworm has been broken to half. But if we find a point K located between f A and f B and stick a needle between, we actually can find 2 points that were being stuck by the needle. So, from this example, we can see that if a function is not continuous, it can, if a function satisfies the intermediate value theorem, it's not necessarily a continuous function, but a continuous function will 100% take on the intermediate value theorem.
Satisfy the inverse statement.
Satisfy the statement of the intermediate value theorem.
so I want to talk about the limitation of intermediate value theorem. It is a very useful tool when we use it to solve our math problem, but sometimes it has many limitations that we can use it. So I want to talk about two limitations. The first one and the second one I will talk about later.
刚刚那个是什么？
我不知道。
哦，那跳掉的是就是自己投掉。哦，那没关系，再修改。
The first one is we don't know when or how many times a particular y value was attained.
可以，那是白板，可以直接写的，直接写的。欢迎参加，欢迎这个是白的，那是没水的，到底会是？然后直接在上面。
Okay, so this is one of the continuous function. So the function maybe look like this, and maybe it will look like this. The k is the particular y value, and the blue one it reaches the particular value one time, and the other reaches 3 times. Okay, then the next one is we don't know whether or not y value is greater than k value or smaller than k. This one is bigger than the most one. It may be bigger than the FB and it may be smaller than the FA. And here's an example. Do anyone know who he is? I want to talk about the cutest and the most handsome professor. Professor Yan. He likes motorcycle a lot. So the d of t function, the x-axis is time, and the y-axis is decibel, the 分贝, 运行分贝. And between 0 and 10 seconds, we can know the function. And we can tell that the y value of the start point is 100, and the end point of y value, the y value of the end point is 35. So, and also this function is a continuous function. We know that every value between 35 and 100 has been reached. However, we can tell that is there any y value bigger than 100 or less than 35 has been reached? And the smaller. Also, we can know that how many times or when a particular decibel was attained. Okay, so Emily, can you tell the difference between the two pictures?
Yes. The first one must be vroom, but the second one is vroom, vroom. Okay, so there is a question. If the noise limit is 110 decibel, should the sexy man be ticketed? Anyone? Hi, Auntie. Will the first man be ticketed? Yeah. No. Okay. The first man is he behaves well, so he will not be fined. And the next man, he will be fined. The next one, the noise limit is 100 decibel. So, how many times will the second man be fined? 3, 4. You are wrong. There. Yeah, the correct answer is 4. And now the last topic, determination of roots. We learned it long time ago, and sometimes we just use it but don't know why. My math teacher said that if you can find the two y value, the y value of 2 is -1, and the y value of 3 is 3. So it is negative and it is positive. So there must be a root between 2 and 3. We all know that, so pass it. We know that the determination of root is a special application of intermediate value theorem. So there is a conclusion. Every continuous function is the intermediate value theorem. And the next one.
The inverse statement of the intermediate value theorem is not necessarily correct. Oh. 因为像是我们刚才说的，
假设这个函数是断裂的，但是它每一个 y， 它在区间内的，在它的两端点区间内的每一个 y 值都有一个对应的点，那即使它中间是断裂，它还是能够有中间值定理的特性。所以如果是我们知道一个函数是连续带点符合中间值定理，但是我们不能因为一个函数符合中间值定理，所以就决定它是连续的。
哦。好，这一组报告跟其他组报告最大差别在哪？全英文吗？不是全英文。你有没有发现他们的那个字很少？他们简报上面的字几乎都是字类。有发现吗？我们没有字。好，很好，来继续。那第三个 conclusion 是，
intermediate value theorem ensures that a graph takes on every y value in the function's domain, but it does not indicate how many times the value is reached, or whether y value is greater or less than fa and b were reached.
Thank you.